Imagine a world where Microsoft and Intel never took over, and Windows wasn't a thing. What device would be on your desk now? What type of computer would it be? Would it be by Atari? By Commodore? Somebody else? Well, come with me today as we step into a mirror universe where that never happened, as we look at RiscOS on a Raspberry Pi, and maybe look at a bit of BBC Basic as well. This is RiscOS. It's running on my Pi 400. Looks a bit familiar, doesn't it? There's a mouse, there's icons, there's windows, you know, all those basic things we expect from modern computers. It has a few curious user interface choices though. RiscOS comes from the Wild West of computing, where nobody had worked out the rules. So, like, for example, there's no file selector. Instead, you drag icons out of files on the save menu into the folder that you want. And the mouse has got 3 buttons. All of them do something specific. And unlike a modern operating system, where 90% of your mousing is done with the left button, you'll be clicking all 3. They all do something different, and it's all required to use the interface. It even has an app store that downloads new software from the internet. Well, so far, so what, you know, it's an operating system, it's on a Raspberry Pi, and it just looks a bit different. You know, I've probably just reskinned Linux or something, with a weird window manager. I mean, everything on computers is Linux after all, that's just what we've evolved into. What if I told you this operating system came out in 1987, and it was originally developed on the BBC Micro? RiscOS is a graphical operating system for their then new Archimedes line of computers. RiscOS is its own thing entirely. It's like discovering a lost tropical island that has somehow totally detached itself from the rest of the world. At one point we went left, they went right, and we've just diverged. It hasn't even gone the way of modern operating systems that insist on having different users, logins or administrators. So, how did I get this on my Pi then? Is it some sort of emulator? Did I have to do some crazy hacking to make it work? Let's find out. So, running it on a Pi is really easy. You literally just open the Pi imaging tool. You're going to choose an operating system. You're going to other general purpose operating system. And then there it is, RiscOS Pi. And that's it. You then burn it to an SD card, put it in your Pi, boot your Pi up, and it's running. Although then, once it's booted up, you might get a bit stuck. There's not a lot to do. Like, it doesn't come with anything extra, you just get the operating system, and a few little utilities. But that's not the fault of the operating system. Remember, this is from a time before the operating system came bundled with tons of free crap nobody cares about. It's not a distribution like Linux, so it doesn't have 6 different web browsers, random games, a copy of a thing that's not quite Microsoft Office but everyone insists is good enough, and dubiously named art packages. It fits the Pi quite well, you know. It's really fast, it's really responsive. And the Pi CPU is also a direct descendant of the original ARM CPU that Acorn created for the Archimedes back in the 1980s. So this really is a modern Archimedes in a way. Enough history lessons, let's do some coding. There's a really fun feature in RiscOS where there's a command line underneath the graphical interface. All you do is press F12 and up it pops. And in there you can type in BASIC. Look, it's BBC Basic, actual real BBC Basic version 5. So it's what we know but new and improved. Although not so new and improved that they thought to remove line numbers. I guess some things never change. I also need to get across the fact this is not running in an emulator. None of this is emulated, it's running directly on the Pi's hardware. Even BASIC. It's a first-class part of the operating system. A PC equivalent, I guess, would be discovering a hotkey in Windows 11 that let you drop into the original Microsoft BASIC the original 8086 machines had built into their ROM. The thing that allowed Acorn to create the ARM CPU in the first place was the BBC's expansion ports and the power of its particular BASIC dialect. You can embed assembly code directly in BASIC. We're not talking lines and lines of hex that you have to painstakingly copy out that someone else had assembled for you, and then a little BASIC loader, such as we found on the Spectrum. No, the interpreter in BBC BASIC contains an actual assembler, as in you can feed it on the original BBC, 6502, or Z80 assembly. On the Pi, it understands more modern ARM assembly because that's the chip. And I believe it's running natively on the CPU. This is where I'd show you some ARM assembly and how fun it is, except I don't know any. So let's play with BASIC instead. So if you follow the same kind of people that I do on Twitter and Mastodon, you'll have no doubt discovered this thing called the BBC Microbot. If you've not seen it, it's an emulator that's running as a bot, and you can send it tweets that contain BBC Basic code. It then runs the code and will send you back a GIF of the output. And then it'll put your code onto a big website that's got everyone else's little programs running as well. And it's quite cool. You can see what other people have done and get ideas off them. Now that's kind of inspired me to do my own coding. Now I don't want to do it just on a BBC. I want to do it on something a bit more interesting. It somehow feels right running BASIC on this. And the fact that you just press a key and you're straight into BASIC. You know, this is a computer with an ARM CPU in it. ARM CPUs were created on a BBC Micro using BBC Basic. So this somehow feels very complete. I quite like this concept. Coding on it though does involve using BASIC, which is slightly painful compared to today's modern standards of programming. So to help me get into the spirit of the thing, I use this book, which I should be showing on the screen to you now, which has got lots of graphical things inside it. And it's got some nice examples of how to draw patterns and things on the screen. So here's a simple little pattern, and if I run it, there we go. Now this is a bit that confused me quite a lot. You'll see like the screen is wrong and it's off the corner. This is just me completely misunderstanding how screens work on the BBC. I'm used to it being a square where 00 is in the top left corner. On a BBC it's more like a graph. So you've got the origin and then you've got positive and negative X and Y. And you can move the origin somewhere. And it's not dependent on the screen resolution. This actually causes quite a lot of trouble for me capturing this because my TV and my capture device think they're running at 1080p. The machine itself, if I go back into the settings, if I go into the video settings for this, it thinks it's running at 720p, but my capture device thinks it's 1080. So what I did was I wrote a little program just to kind of see what the screen looked like. And all this program does is it tries to set a 640 by 480 mode and then tell me how big the screen is and put a point in the middle and draw a box around the edge. Because the screen resolutions don't quite match the shape of my TV, I've got a widescreen telly. This is aimed at 4:3 monitors. So if I run this, you can see that apparently the width and height of the screen is 1280 by 960, which is nothing like 720p, and the middle is at 640 by 480, which at least mathematically makes sense. You might notice it's a bit fuzzy. There is pixel scaling and things happening to this image, and I have no control over it. It's what happens on a BBC. It happened on the original ones too. This code would run on an original BBC. That mode line wouldn't, because they don't have these modes, these are new, but the general idea would work and it would scale it as well. So if the text on this and the graphics look a little bit fuzzy, that's just how it looks to me as well. It's just what happens when you try to mash a screen down into a different shaped set of pixels. But then I kind of figured out all of this graphical stuff and I managed to make that pattern work. And there we go, got a nice flashing little pattern thing. You notice you press escape and it's still in whatever mode it is. There is actually a flashing cursor at the top and there's my code. So you just have to reset the screen. So something I wanted to do was create a couple of channel idents and logos and things that I can use in my videos. That'd be quite nice if we've got a few little bits and pieces that I've created in something like BBC Basic instead of using After Effects and Premiere that I normally use. So I set about creating my logo. So let's have a look at that. Now I'll put it on the screen, but my logo is pretty much a very simple letter, which if you imagine each stripe of it is made from little blocks. There's 7 blocks wide, so all I have to do is draw rectangles of that size. So what I did was use the graphics mode and I started drawing rectangles on the screen, and I quickly realised typing out code in this is very, very painful. Like, the Raspberry Pi keyboard's not that great to type on, but also trying to type out BASIC is very awkward. If you look at this stuff on the screen, it's not indented, it's all in capital letters, none of it's coloured. I can space it out a little bit, but then if the lines get too long and they wrap, it's just really hard to read it. I could use a bigger screen resolution, but then the text is tiny. So, you know, I figured I'd program my way out of this problem. And I realised I could define the graphics using an array, and then some code to print out rectangles based on the array. There's a little sneaky for loop in this and stuff, so if I run it, I get that, which is kind of decent, you know, don't mind that. But it's just a static image, really. I could draw that in Photoshop in 20 minutes, so I don't get why I need to have it written in code. It doesn't look very interesting. I want something a bit more creative. So I had a bit of a think, and I remembered that the BBC was quite often used with teletext. They deliberately had a mode that was very compatible with a broadcast TV station. And that mode still exists. That's that mode 7 thing that I've been using, which is nothing to do with mode 7 on a SNES. This is not flattened 2D that looks 3D. This is just text only, but very, very compatible with old 1980s TV equipment. I guess the closest thing to relate it to is using ANSI escape sequences on a terminal or in MS-DOS. So I set about trying to create my logo using this. And again, being a bit crazy, I thought I'd program my way out of this to save effort somehow, although a lot of this code is far more complex than it should be. Like, I created a function to draw one part of the logo, depending on how wide each part should be, and there's a bit of a go-to going on in there. BASIC gets a bad reputation because it has go-tos in it, but if you've ever written any assembly, you can see how BASIC appeared. Assembly programmers turned that into words, but it's still got the same logic that you jump forward through the code and maybe jump backwards through it to specific parts. Just instead of labels, you've got line numbers in this one. Now this one looks much more interesting. Quite like this one, I think I'm going to use it. In fact, you might see this in other videos. Again though, it's not very interesting to look at. It's alright for like 2 seconds at the beginning of a video, but I want a little bit more interactivity. And this is where I started looking at those BBC Microbot examples. And there's some where they have sort of interesting glitchy effects. And I had a go. Oops, wrong one. Right, let's load up. So to make the logo look a bit more interesting, what I did was I found one of those examples from the BBC Microbot, and in it there's one where it does this glitchy effect on the screen. If you look at line 180, which is sort of the middle of the screen of this, there's a command that does something to the video hardware and then loops over itself as quick as possible. If I run this, and it is a little bit flashy, so watch out if flashy things bother you. But you can see it kind of strobing away, and there's stuff going down the side of the screen. And if you look now down the side, it says escape at line 180. And if I list the code, it lists it all in a little column. So let's reset the screen. Now what this is doing on line 160 to 170 is it's creating a 1 character wide by 24 column tall text window, and then setting the cursor to the top corner of it. I think line 180 just sends random control codes to the display chip, and occasionally some of them it doesn't know what to do with, so it just prints a big line across the screen and kind of messes up its own internal timings. When I was messing with this earlier, I managed to actually scramble the screen to the point I had to reboot the machine. It just kept printing garbage down the edges of the screen, even if I quit BASIC and went back into it. So clearly this does something quite deep and fundamental in the hardware. almost feels like you're torturing it a bit. Quite like it. But another one that I managed was this one. So another example program I found just kind of randomly drew across the screen in random resolutions, printing text on it randomly. And I kind of adapted that a bit. So I've got this thing which just does that all over the screen. And, you know, look, it's gone into a weird screen resolution now, so go back. I figured I could combine that idea with my logo. So now, let's run this. I've got my logo and that kind of thing. And I think I might stick this at the very end of the video, you know, that can sort of be the last thing that's on the screen. Not for very long though, it's a bit mad. So there we go, that's some creative coding on BBC Basic, running on a Raspberry Pi without any emulators. It's quite cool. I'll do this again. BBC Basic's quite special. I used to use it when I was a kid because I got an Acorn Electron, it's my very first computer, and it didn't have many games, so I spent ages typing things out the manual into it. And I got to learn a bit about it, but never anything in any great depth. The other thing that's quite cool is that you've probably heard the stories of how the BBC was used to help create ARM CPUs, and that they prototyped it on a BBC. Well, you can do that because apart from being really well connected with peripherals and things, BBC Basic allows you to run assembly language code inside BASIC. It will directly assemble it without you having to type in all the hex stuff like you would on a ZX Spectrum. That continues now on the Raspberry Pi. You can program it using ARM assembly, so you can talk directly to the hardware through BASIC. And I might try that one day. Sounds quite interesting. But until next time, I'll see you later.